For example number 2, we want to use the table of integrals to find the following. And if we take a look at this, we have x squared divided by the square root of 5 minus 4x squared. So if we take a look at the table of integrals, okay, well, we want to look for the form. So this is if you look from 1 through 20, and then from here, from 21 on, it gives you the forms involving square root of a squared plus a squared. And if we go down a little further, from here, we have forms involving the square root of a squared minus u squared. And if we look at number 34, this is the one that we're going to use with our table of integrals. So we're going to take this and paste it in here. So we're going to use this as part of our particular problem. So let's go ahead and begin. Now, what we want to do is we want to be able to find some sort of substitution. And in this particular example, we're going to let u equal 2x. And therefore du is going to equal 2 dx. And then dx is then going to equal 1 over 2 du. Okay, the reason why we're going to do that is if we look at our original question, so we have x squared over the square root of 5 minus 4x squared dx. Now, if we break this down a little further, again, we have x squared all over the square root of 5 minus, well, what do you have to square to get 4x squared? Well, that's going to be 2x. Right? And then what would you have to square to get 5? Well, that would be the square root of 5. So now, if we use our substitution, okay, we know that since we have dx, we can then apply our substitution. So we know that x if we solve for x here, and we divide everything by 2, we know that x is going to equal u divided by 2. So what we're going to replace with x squared is going to be u divided by 2 squared divided by the square root of 5 minus, what do we say that u is equal to? We know it's 2x, so that means you're going to have u squared in the denominator. And then dx we found to be 1/2 du. So if we continue, we then know that in our denominator, technically a squared is equal to 5. And therefore, if you take the square root of both sides, then a would equal the square root of 5. So why do we need to do that? Well, if we take a look at step 3, okay, so again, our original question was x squared divided by the square root of 5 minus 4x squared dx. Okay. And so what we have, I'm going to rewrite what we got up there, which was u divided by 2 squared all over the square root of 5 minus u squared times 1/2 du. So if we simplify, then in our numerator, we end up having u squared over 4 divided by the square root of 5 minus u squared times 1/2 du. And then ultimately what that's going to do is that you have 1/8 times the integral of u squared over the square root of 5 minus u squared du. So the next step is then to bring down this form. So I'm going to go ahead and copy that form, and we're going to apply that. Here. So now what this is going to equal is we have 1/8 times, we have negative u over 2 times the square root of 5 minus u squared plus, if we look at the a squared, and that means we got the square root of 5 squared over 2 times sine inverse of u over the square root of 5 and that entire thing is plus c. And then last, we just need to distribute that 1/8 and replace u to be what we replaced u to be, which was 2x. So we have 1/8 times negative 2x over 2 times the square root of 5 minus 2x squared plus 5 over 2 times the sine inverse of 2x over the square root of 5 plus c. And now we can just go ahead and simplify and now distribute the 8. So we know that we can simplify the 2's. And so we end up with negative 1/8 times the square root of 5 minus 4x squared. And distributing the 8th to this term is going to be plus 5 over 16 times the sine inverse of 2x divided by the square root of 5 plus c.